Here we're going to take a look at the conditions of rectangles, rhombus, and squares. This video is really a converse of the previous video. So what we're doing is we're looking at if something's provided, then we know that it is a rectangle, for instance. If I have a parallelogram, so these opposite sides are parallel to each other, and there is a right angle, any one of these angles is a right angle, then this parallelogram has to be a rectangle. Because if this one and this one are same side interior angles of this parallel and a transversal. And these parallels with this transversal make this a right angle. And these parallels with this transversal make this a right angle. All through same side interior angles for parallels and a transversal. If the diagonals of a parallelogram are congruent, so if this line here is congruent to this line, then that parallelogram is a rectangle. And we have two conditions when provided with can make our parallelogram into a rectangle. Now let's look at a rhombus, where I have parallel sides. Now if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So if this side is congruent to this side, then we've met the condition to meet a rhombus, because we know that this side must be congruent to this side, and we know that this side must be congruent to this side. This is simply through parallel lines cut by a transversal. So we're going all the way back to that very beginning. If the diagonals of a parallelogram, so if this line and this line meet at 90 degrees, then that parallelogram is a rhombus. And if one diagonal of the parallelogram bisects the pair of opposite angles, so this line is the bisector of the angle of both of those angles, then the parallelogram is a rhombus, and we would be able to use the side angle side congruency for triangles to prove this. When it comes to squares, if it is a parallelogram, all four sides are congruent. Back myself up here. If it is a parallelogram and all four sides are congruent with 90 degrees, then it is a square. If it is a parallelogram and the diagonals bisect each other and are congruent to each other, then it is a square. So we're able to use all of those same things from before, but working in opposite order. And I don't feel that it's really worth the time on the proof, because I feel that it's very straightforward for students in geometry class. Remember, math rocks with a capital M.